All right, this is Chemistry Unit 5. We're talking about something new in this unit, ionic bonds. It's a type of chemical bond. First, we have to figure out what is an ion and how does it form. In this unit, we will discuss ions, and ions are charged particles. First, a quick review of atoms and elements. Remember, the identity of an element is determined by the number of protons in the nucleus. Protons have a positive charge. Each proton has a charge of, we would say, +1, positive 1. Neutrons are also in the nucleus. They have a neutral charge, which means they are neither positive nor negative. Since the nucleus contains only positively charged protons and neutrally charged neutrons, the charge of the nucleus, any nucleus, will always be positive. Then there are electrons, which have a negative charge. Each electron has a charge of -1. They occupy the area outside of the nucleus, so the area that surrounds the nucleus is always going to have a negative charge. So far, we've only considered atoms to be neutrally charged. Remember, in Unit 3, we were talking about electrons, and we were treating them as if the number of protons and the number of electrons are always equal. That was useful then, but now that we're talking about ions, we're going to have to treat them differently. In a neutral charge atom, the number of protons and electrons are equal, and the net charge of this atom is 0. It means it's neutral. Net charge is 0, equal number of protons and electrons. Remember, we only consider protons and electrons when we're talking about charges. So, a very useful thing to remember here, the net charge equals the number of protons minus the number of electrons. An ion is an atom that does not have equal numbers of protons and neutrons. So remember, for any given atom of any given element, the number of protons is not going to change. But the number of electrons in an atom can change. So here's what happens. An ion forms when an atom gains or loses electrons. An ion is an atom that does not have a neutral charge. So the charge of an ion is going to be a whole number, and it's going to be a number other than 0. So an ion could have a positive charge, or it could have a negative charge. Usually when we refer to an atom, we use the atomic symbol. But it's important for us to distinguish between atoms and ions because they're not exactly the same. There are different numbers of electrons. So an ion does not have the same number of electrons as a neutral atom, and so we need a system that indicates the charge of the ion. An ion by itself is written using the atomic symbol, followed by the charge, which is written as a superscript. Remember, a superscript is written above the line. It's not an exponent, but it is up there like an exponent would be. So let's just look at a couple of them. We won't do very many. An atom, for instance, sodium. Its ion ends up being Na plus. So what this means is that it has one more proton than electrons, which makes it a little bit positive. Cl minus, Cl, that's chlorine, and its ion is Cl minus. So with these two, this is really saying that sodium has a positive 1 charge. But this is an instance where if you write the plus, the 1 is not necessary, so we leave it off. There are some other instances, so let's look at nitrogen, for example. This is its atomic symbol for the atom. This is the symbol for the ion. And it says N3 minus. So this is nitrogen, and it has a -3 charge. And it's just a common thing when we talk about charges that the number comes first and then the sign comes after it. You could have things with positive charges, for instance. Let's talk about, calcium. As an atom, here's calcium. It has 20 protons, 20 electrons. As an ion, it becomes calcium 2 plus. It still has 20 protons, but now it's only got 18 electrons. And so the positives are greater than the negatives. So we end up with this positively charged ion. So the reasoning, some elements are not stable due to their electron configuration. So atoms will tend to find the most stable configuration possible. The most stable electron configuration is a complete set of 8 valence electrons. Complete set of 8 valence electrons, which we call a complete octet. So OCT, as a prefix, it means 8. So you've got octagon, you've got octet, you've got octave, octopus. Those all, it means 8. So a complete octet is 8 electrons, 8 valence electrons. So this also happens to be the electron configuration of a noble gas, of any noble gas. So remember, we have group 18. Group 18 is the noble gases. And remember, to find the valence electrons for groups 13 through 18, we subtract 10. And so that tells us 8 valence electrons. So this complete octet of 8 valence electrons happens to be the electron configuration of the noble gases. An ion forms. Remember, an ion is an atom that does not have equal numbers of protons and electrons. So an ion forms to achieve a complete octet, and it makes the atom more stable. So I'm going to change colors here, keep things separate. So let's look at sodium. Sodium, and this is just Na, so we're implying that it's a neutral atom right now. Sodium on your periodic table is atomic number 11, which means 11 protons. When it's neutral, that means 11 electrons. So its electron configuration looks like this: 1s2, 2s2, 2p6, that's 10, 3s1. It's a little more helpful to look at the noble gas configuration because we get more information from it. So this 1s2, 2s2, 2p6 is the electron configuration of neon. And then we have one valence electron, it is the 3s1. And so for our electron dot diagram, it might look something like this. And this single electron, it's further away from the nucleus than any other electron in this atom. This electron tends to get lost pretty easily. It just kind of disappears, a different atom will take it away. And so what happens here, this electron, the valence electron, our interesting electron, disappears, and we end up with sodium that now has 11 protons and 10 electrons. So remember my idea of net charge. It is number of protons minus number of electrons. And so for this one, we've got 11 minus 10, which means the net charge is positive 1. And that's how I come up with a sodium ion that has a positive 1 charge, or we would just say Na+. This sodium ion right here has 10 electrons. Remember, it lost this one, which means that this one is the one that was lost. So the electron configuration of this sodium has the electron configuration of neon. And this is how we could describe it, because we want an ion to have a complete octet. We want it to have the configuration of a noble gas. And so when it loses this one electron, now it has the electron configuration of neon. All right, so I'm going to change colors again and look at a second. So I'm going to look at Cl, chlorine. Chlorine has 17 protons, and when it's neutral, it has 17 electrons. So let's do the electron configuration of a neutral chlorine first. And it looks like 1s2, 2s2, 2p6, 3s2, 3p5. And if you need to double check your count, 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 5 is 17. 17 is what we were looking for. Its noble gas configuration is neon, representing the first 10, and then we represent the outer energy level, 3s2, 3p5. Its electron dot diagram, 1, 2, 3, 4, 5, 6, 7. Here it is. It's showing 7 valence electrons, just like the noble gas configuration is showing us 7 valence electrons. And so here's what happens. Chlorine does not want to lose 7 electrons. That's a lot of electrons to lose. It's a lot easier just to pick up a different electron from somebody else. There are atoms out there who are trying to give away a single electron, and so it makes it pretty easy for chlorine to grab one. For instance, it sees the sodium over here, which has 1 electron that it's not holding on to very tightly, and so it's just going to take it, and it's going to take it to itself. And so what you end up with for this electron dot diagram, I'm going to represent it just a little bit differently. So Cl, and it now has 8 electrons in that outer energy level. It's now negative. So as far as protons go, it had 17, and now it has 18 electrons. And so the charge of this chlorine is -1. So remember, we have to tell a difference between a neutral atom and an ion. And so what we have to do for this electron dot diagram is put it in some brackets, and we're going to put a negative here. That means that this chlorine has a -1 charge because of this electron that it picked up from the sodium. So it now has 18 electrons. And you have a noble gas that has 18 electrons. So we look at our periodic table, and it is argon. And so we could say the electron configuration of this chloride ion has the electron configuration of argon. If you think back to Unit 3, I told you when you're talking about argon itself, you could not say that argon has the electron configuration of argon because we needed to see the stuff in the outer energy level. Well, this is chlorine, this is not argon. And the fact that chlorine, Cl minus, has the electron configuration of argon gives us a lot of information. And so this one, in this situation, it is okay. An ion forms when an atom gains or loses valence electrons. So there's a thing called the octet rule. The octet rule tells us that atoms are most stable when their outer energy level is completely filled. So the octet rule says that this chloride, the Cl minus ion, is more stable than this neutral chlorine, which is short 1 electron. It tells us that this sodium ion, which has the electron configuration of neon, which is a very stable configuration, this sodium ion has a much more stable, it's much more stable than this sodium that has just 1 too many electrons for a stable configuration. So that's what the octet rule is saying. Atoms are most stable when their outer energy level is completely filled. This means that atoms need 8 electrons in the outer energy level. And to do that, they become more stable by gaining or losing valence electrons, and it forms an ion. Ions are meant to fulfill the octet rule.